Right, so question 9. It's a car towing a trailer, light tow bar, and I'm given some resistive forces. So let's get that all sketched out. So, okay, so this one is going to be my car. So that one has a mass of 900 kilograms. The trailer has a mass of 300 kilograms. The driving force of the car, I'm told, is 1,200 newtons. There's going to be equal and opposite tension in the tow bar. The car has a resistive force of 200 newtons, and the trailer has a resistive force of 100 newtons, and the whole thing is going to be accelerating to the right. And so they don't actually tell me the acceleration, but I need to show that it's 0.75 for part A. Okay, so I'm going to need to model the whole thing as a single body because I don't know the tension and I currently don't know A. I know what it should be. So if I model the whole thing as a single body, the driving force is 1,200 newtons. The total resistive forces are 300 newtons. That's the 100 plus the 200, and tension is going to cancel because that's equal and opposite both those values of T. The total mass is 1,200 kilograms. So if I use F equals ma, and I'm taking the right as positive, so 1,200 minus 300 is mass times acceleration, so 900, 1,200A, so A is 900 over 1,200, which is 3/4 or 0.75 as they asked for. Okay, so just with a show that question, just make sure you definitely show enough marks to justify that you know that's come from, you haven't just sort of fudged the numbers to make it work. Okay, then I want the tension in the tow bar. So I can either look at the trailer or the car. So I'm going to look at the trailer. So that's being pulled along by the tension, and I know the resistive force is 100 newtons, and the mass of the trailer is 300 kilograms. So if I use F equals ma on the trailer, T minus 100, so the force, and I'm going to the right, and we now know the acceleration to the right is 3/4 or 0.75 meters a second squared. So taking the right as positive, T minus 100 equals the mass of 300 kilograms times the acceleration, which we now know is 3/4. And obviously, even if you hadn't been able to answer part A, you could still have used that value to answer part B. So 300 times 0.75 and then plus the 100 gives me a tension of 325 newtons. Okay, so just double check those answers before we carry on. 0.75 meters a second squared and 325 meters. Okay, cool. Right, so part C, so 7 marks. So this is an exam style question. So 7 marks means there's going to be quite a bit to think about. Okay, so let's draw the car and the trailer now together. Right, so the car is moving along the road when the driver sees a set of traffic lights are turned red. He reduces the force produced by the engine to 0. So there's no longer a driving force, but he is applying the brakes, and they are going to provide a resistive force on the car. So this is my car, which was 900 kilograms. This is my trailer, which was 300 kilograms. So they still have, so given the resistances to motion are unchanged, so they still have let's get this the right way around. So the trailer had 100 Newton resistive force and the car had the 200 newtons, that's going to be sort of due to sort of friction on the road, air resistance, that kind of thing. So it's looking messy, isn't it? Let's try that again. So 200 newtons. Okay, and then if you think about what's going to be happening to the rod, if we're now slowing down, that's going to be working, the thrust in that is going to be working in that direction, because it's going to be pushing back on the trailer trying to slow it down, but then it's also going to be sort of pushing against the car. And again, those values of T will be equal and opposite. So I'm going to have to come up with simultaneous equations here. So if I just look at the trailer and use F equals ma. So I know it's decelerating. So I know its acceleration is off to the left. I know it's slowing down. But I don't know the value of that. And they don't ask me to find the value of the acceleration. So that it may be for those 7 marks, though, that I need to find acceleration in order to find F, or it may be that I can eliminate A somehow. Okay, so let's think about that. So if I look at the trailer, and let's take left as positive, so 100 newtons, let's get rid of the units. Okay, so 100 plus T, so they're both going to be trying to slow it down. Yeah, the 100 newtons was always a resistive force, and it is still travelling to the right. So the 100 newtons is, that's worth thinking about. The 100 newtons is still going to be working to the left, because even though it's slowing down, it is still travelling off to the right until it reaches a halt. So 100 newtons is still slowing it down in that direction. The thrust in the, what are they referring it to as? The thrust in the tow bar is also going to be slowing it down, and that must equal its mass of 300 times acceleration. And in fact, I'm told, and if I go back to the question, I'm told that the magnitude of the thrust in the tow bar is 100 newtons. So that's going to be 100 plus 100, so 200 is 300A. So even though they didn't ask me for A, it's obviously very easy to work it out from that. So A is 2/3 of a metre a second squared. Okay, so now if I look at the car and use F equals ma in the car, so, and again, let's take left as positive. So I've got this braking force F, I've got the resistance force of 200 newtons. Thrust is actually going to be pushing against the car. So that's going to be sort of stopping it slowing down. So minus the thrust equals the mass of the car times acceleration. And I know that thrust is 100 because they told me that in the question. And I also know that acceleration is 2/3, so let's plug those numbers in. So 900 times 2/3 plus 100 minus 200 gives me a braking force of 500 newtons, and I think we saw that answer before. Let's just check it.